In section 5.5, we're going to start working with negative exponents, exponents that are negative integers, and then scientific notation, which makes use of exponents to represent really, really large numbers and really small numbers easily. So we'll simplify expressions that have negative exponents, and all of the rules that apply for exponents also apply for negative exponents. So your power rule, your quotient rule, your product rule. So we'll practice those, and then we'll write numbers in scientific notation, or we'll look at scientific notation and convert those numbers back into standard form, and then just perform some operations with scientific notation to make sure we're comfortable with that. So if I have a number raised to a negative exponent, so that's 5 to the negative 4th, I'm going to take what's being raised to the negative exponent, it's in the numerator, I'm going ahead and put it in the denominator with a positive exponent. So this is like 5 over 1 to the negative 4th. We're going to change that to 1 over 5. And that's going to be to the positive 4th. We've changed this from having a negative exponent to having a positive exponent. And if you were to use your calculator and find out what 5 to the 4th is, it's 625. Or if you were to put 5 to the negative 4th in your calculator, you'd come up with a decimal. If you press convert to fraction, you'll get 1 over 625. Now here, 7 times x to the negative 3rd. Here's the trick question. Is the 7 being raised to the negative 3rd? No, it is not. That would be 7x in parens being raised to the negative 3rd. The 7 is not being raised to the negative 3rd, just the x is. So just the x is going to go in the denominator. The 7 is going to stay in the numerator. Just the x to the 3rd goes in the denominator. So rather than x to the negative 3rd, it now becomes x to the positive 3rd, but rather than being in the numerator, it is now in the denominator. How about here? Here I'm actually going to add 4 to the negative 1 is I'm going to move that 4 into the denominator. Plus 3 to the negative 1, I'm going to move 3 to the first into the denominator. Now you cannot, you could put this in your calculator and get the answer, but if you had to do it longhand, you cannot add exponents and add fractions unless they have the same denominator. So I would have had to multiply to give them both the same denominator. I'd give them both the denominator of 12. So this would become 3/12 plus 4/12. So my answer would be 7/12. But really what we were practicing is writing numbers, rather than having a negative exponent, write it with a positive exponent. Now here the negative 4 is the base. So the negative is also being raised to the negative 2. To rewrite this, this would become negative 4. The base stays the same, just the exponent becomes positive. So that's going to be 1 over 16, because negative 4 times negative 4 is positive 16. And r to the negative 6th is the same as 1 over r to the 6th. So go ahead and try practice 1. That's writing negative exponents as positive exponents moving into the denominator. Now in example 2, you see we have some expressions in the denominator raised to a negative exponent. We're going to rewrite these as take them out of the denominator and put them in the numerator with a positive exponent. 1 over y to the negative 7th, I'm going to take this y to the negative 7th out of the denominator, put it in the numerator, and use the positive exponent. 1 over 3 to the negative fifth is the same as 3 to the positive fifth. This has a negative exponent. This has a positive exponent. And if you were to put 3 to the fifth in your calculator, you'd get 243. All right, for this next example, x to the negative fifth is going in the denominator, and we're going to get a positive exponent. Y to the negative 2 is going to go in the numerator and get a positive exponent. Negative into the denominator becomes positive exponent. Negative in the denominator goes in the numerator and gets a positive exponent. All right, we'll do the same here. 11 squared in the denominator, and we're going to change this to 3 to the third in the numerator. Negative 2 in the numerator, positive 2 in the denominator. Negative 3 in the denominator, positive 3 in the numerator. And so 3 to the third is 27, and 11 squared is 121. That's probably how we're going to write that. All right, so you go ahead and try practice 2. So as we go into example 3, all of the rules that applied for exponents, positive exponents, also apply for negative exponents. All right, so this is x over x to the negative fifth. Two ways to do this. The first thing I could do is change that x to the negative fifth by putting it in the numerator and making it x to the positive fifth. So what is x to the first times x to the fifth? That would be your answer. Or I could use the quotient rule. That would be 1 minus negative 5. Because when you divide like bases, you subtract the exponent. So that would be x to the 1 plus 5, which, you know, that is the right answer, regardless of if you change it to a positive exponent first, or if you leave it as a negative exponent and apply the exponent rule. 7 divided by t squared. Nothing's happening with the 7, but we're moving that t squared up into the numerator, giving it a positive exponent. Okay, we'll do this one two different ways. A to the negative 10th divided by a squared. We can make that a to the negative 10th as a to the 10th with a positive exponent in the denominator. And that's going to be multiplied by 1 over a squared. So that would be 1 over a to the 12th. Or I could have used the quotient rule. That would be negative 10 minus 2, a to the negative 12th. And we want to write our answer with positive exponents only, so rather than a to the negative 12th, we'd put that in the denominator. Same answer. And then for this one, 3/5 to the negative thirds is the same as 5/3 to the 3. I could have done that in 2 steps, put the 3 in the denominator, put the 5 in the numerator, but I just did it in 1 step. So that's 5 to the third over 3 to the third. 5 to the third is 125, 3 to the third is 27. All right, so why don't you try practice 3? And classroom example 4, remember when you raise a power to a power, you multiply the exponents. So A, -4 times -5 is +20. With my base B, 7 times -5 is -35. And if I want to write my answer with just positive exponents, my A is going to stay in the numerator, but my B is going down in the denominator so it can have a positive exponent. This fraction raised to the -2 is the same as move the denominator up, move the numerator down, and give it a positive exponent. So that's the same as y squared over 9x third squared. So my final answer would be y squared over 81 x to the 6th, because when you raise a power to a power, you multiply the exponents.